Bismillahirrahmanirrahim. Today, we will learn about probability. Let us enjoy for the rest of the slides. Have you heard about probability before? Well, let us find out. Well, probability is the measure of how likely an event is. It is also known as the ratio of the number of favorable cases to the number of all the cases. Probability is also equal to the number of outcomes favorable to the event divided by the number of all possible outcomes of the experiment. Do you want to see example? Let us see together. Here we have three probability words used in our everyday lives. For example, probably it may rain today. In this sentence, we have the probably, which shows that it may or may not rain for that particular day. For number 2, let's see the second example. He may possibly join politics. The role of the word possibly here is the same with the word probably that we have discussed just now. Let's see another example. I probably get 6s for rolling dice. Here we have the word probably too. The word possibly, probably, and chance convey that there is uncertainty about the events. Now, we move to the terms used in probability. Basically, we have some words or terms used in probability. Firstly, we have event, which is an occurrence of the activity whose probability is being calculated. For example, we are calculating the probability of dice. An event is one roll of a dice. Second, we have outcome, one possible result of an event. For example, rolling a 5 is one possible outcome of rolling one dice. There are a few more terms such as success, failure, sample space, and equally likely outcomes. For example, a baby born is a boy or girl. Its own laws. Let us figure it out. A probability is a number between 0 to 1. 0 means there is no chance for the event to occur. Meanwhile, 1 means that the event will occur. Otherwise, half means that the event may or may not occur. There are a few types of probability. First, we have the probability of an event. The probability of an event is the measure of the chance that the event will occur as a result of an experiment. We have two types of events. First, we have independent events. Second, we have dependent events. Independent events occurs when what it did in the past will not affect the current toss. Here is the example of the independent events. What is the probability of getting a 5 or 6 when rolling a die? So we have to figure out the number of ways it can happen, and then we have to estimate the total number of outcomes. So So the probability is the number of ways it can happen divided by the total number of outcomes. Next, we have dependent event, which is an event that is affected by previous events. Here is also an example of dependent events. For example, removing colored marbles from a bag. Each time you remove a marble, the chances of drawing out a certain color will change. Next, we have the probability of events involving union of two events. Here is the Venn diagram for the union of two events. Well, this is an example of the union of two events. A spinner has three different colors: red, blue, and green. Find A, the probability of red and blue, B, the probability at least one blue. So here is the solution for A. We got the answer, which is equal to 12 over 49. And then as for the solution for B, we have the answer equal to 24 over 49. Now, we go to the probability of events involving intersection of two events. Here is the Venn diagram representing the intersection of two events. This is an example of the intersection of the two events. To make it easy, notice that what they have in common is in bold. Let A be one orange, one pineapple, one banana, and one apple. Let B be the one spoon, one orange, one knife, one fork, and one apple. So the intersection between A and B is one orange and one apple. Second example, find the intersection of A and B and then make a Venn diagram. So here is the Venn diagram representing the intersection of A and B. Next, the probability of mutually exclusive events. Two events are said to be mutually exclusive if they cannot occur at the same time. Disjoint also describes the events to be mutually exclusive. How it be mutually exclusive? Here are some examples of mutually exclusive. This is how to distinguish mutually exclusive and not mutually exclusive events by using Venn diagrams. It is important to remember that when two events are mutually exclusive, then probability of A and B is equal to 0, as there is no intersection between the two events. Here is an example on mutually exclusive. We have a deck of cards. In a deck of 52 cards, the probability of a king is 1 over 13. So the probability of king is equal to 1 over 13. The probability of an ace is also 1 over 13. So the probability of ace is equal to 1 over 13. When we combine those two events, the probability of a card being a king and an ace is equal to 0, which is impossible to happen. The probability of a card being a king or an ace is 1 over 30 plus 1 over 30, which is equal to 2 over 30, which is written like this. Probability of king and ace is equal to 0, and the probability of king or ace is equal to 2 over 30. Next, we are going to take a look on probability distribution. First, we are going to take a look on the binomial distribution. These are the variables in binomial distribution. Now let's see the example. Example 1. In a town, the probability that rain will fall on any day is 0.3, which is the success. Calculate the probability that rain will fall on exactly 2 days in a certain week. So there are 2 steps to solve the question. First step is to identify the parameters. So we have P, we calculate for Q, and we got R, and we got N, and then we substitute into the formula, which is the next step, and then we got the answer. Same method applied for the second example. Second example, 65% of Form 5 students of a school pass the SPM additional mathematics paper. If a sample of 5 students is chosen at random, calculate the probability that all of them pass the SPM additional mathematics paper. So first we have to identify the parameters, and then we substitute into the formula. So we got the answer. Now we go to the normal distribution. This is basically normal distribution looks like. And here is the example of normal distribution. For this kind of questions, we need to refer to the Z-score table, which we will continue in the next week. Don't forget to stay tuned. And lastly, thank you for watching.